Hi, welcome to our parent info session. My name is Heather Urquiza. I'm the Director of Enrollment at Code Ninjas Midland Park, and I'm joined by one of the owners of Code Ninjas Midland Park, Bob Lockwood. Hi, Bob.
Hi there. Thanks for having us, Heather. We're very excited.
No problem. So without further ado, let's get into the main reason that you're here. What is Code Ninjas? Well, that is one heck of a question. So what we are is a learning center that teaches kids how to code primarily by teaching them to do so through video games. Now, what kid nowadays does not like video games? I know I have two boys that are 8 and 9 years old, and that's all they want to do. But as a parent, I don't want my kids to sit in front of a screen all day just passively playing. So Code Ninjas is a good solution for that problem, since the kids are going to be sitting at a computer coding, but it's not passive, it's active. They're learning something, they're able to transfer their creativity into a tangible item that they can share and play, and they have a blast while they're doing it. So what are the advantages of learning how to code, you might be asking? Well, there's a whole slew of them, but the main ones are reading, writing, arithmetic, problem solving, and creativity. And I'm going to get into all of those in just a minute. Will my child have fun at Code Ninjas? This is a good question. And like I touched on before, what kid nowadays doesn't want to play video games? Every kid that I know in this generation upcoming is basically born with electronics in their hands. They spend their screen time usually playing passively, like I had mentioned, but one of the main goals is to get them to actively sit there and think and learn while they're still getting to do something that's fun. So as I mentioned again before, our curriculum focuses on game development. That way we can keep the kids engaged, excited, and having fun. Now, a lot of people think that just because you're learning to code, it takes a certain type of person, and that person can't necessarily be a creative type, but coding is extremely creative. Just like poetry or music or art, children have to come up with an idea and they have to bring that idea in to make it into a video game. So it gives them the ultimate creative license, essentially. They can come in and create their own characters, create their own backgrounds, use their voice in their own video game, and tons more. Their ideas become the scenes, the characters, and the actions. And then those become the backgrounds, the sprites, which are the little characters that move around, and the blocks of code. And then that all in turn becomes a video game.
And as we've talked about together, the backgrounds are like the scenes, like it's the place where everything happens. And the sprites are all of the objects, they're all the nouns, they're the person, place, and things are all the sprites. And then the actions are the blocks. So the blocks are pieces of code that make things happen. So they're actions, so they end up being the verbs. So that's how it all fits together.
Right, it's awesome. So how does coding improve kids' reading skills? Well, at our Code Ninjas, everything is done on a drop-in basis. So the curriculum is self-paced. The kids will read instructions and go through and follow the instructions. They have to learn new terms. It increases their reading comprehension. They have to learn high-end concepts, and they do it all in our dojo with the help of the senseis, but it does improve their reading skills on the whole.
Sure, and I would just add there, Heather, that you know, the kids are having a little bit of a difficult time trying to figure something out, and the senseis are there to help, but at the same time, the senseis are there not to do the work, but to encourage the child to do the work. And the sensei might say, oh, maybe you missed something. Maybe you should go back and read that again.
Yeah. The senseis are absolutely an awesome resource to have in the dojo. And like you mentioned, it's not so much for them to do the work, but it is for them to point the kids in the right direction.
Right, absolutely.
Coding does improve kids' problem-solving skills. This is one of the absolute biggest topics that the kids will cover while they're learning to code. I was talking to Bob a little bit earlier where I said when I was first learning Scratch, I would sit down at the computer and want to make my sprite jump. And I would sit there and go, okay, now how do I do that? So the kids have to, learn all about the blocks and the code later. And then they have to apply that in a way that will solve the problems that they have making their games, essentially. Now, Bob, you said something earlier about preparing them for later in life and work.
Well, yeah, I mean, as we talked, everything's a problem, right? When you look at your work day and you look at all the problems in front of you, you solve those problems today, and guess what? You have a whole bunch more problems tomorrow, right? And that happens with code. So every single thing the child is doing through the process is a problem. They have to figure it out. And it's as simple as something like changing the color of a sprite. That's a problem. How do you do that? So that's just one step. So kids are faced with many, many, many steps. And each one of those is a problem. And every time they solve a problem, they accomplish something.
Absolutely. And we were talking earlier about game development and the fact that you have to go in and debug games and all code really, because code doesn't work sometimes and you have to go in and figure out why it's not working and how to fix the problem. So it's something that the kids will definitely get adept at as they go through their coding education.
Absolutely.
Another big one is math skills. I feel like pretty much everybody knows coding involves math, but what most people don't know is that our ninjas start at the age of 7. So they're coming into our dojo, and meanwhile in school, they're learning addition, subtraction. They're coming into the dojo and they're learning advanced math skills like graphing and X and Y axis and variables, logic even. So they're learning about these concepts way, way earlier than their peers.
Yeah, and I like to jump in on this one because I'm a big advocate for the math skills. But, things like percentage and fraction and a decimal, all of those things happen. A very quick example is the size of a shape. So a sprite is a shape, and they'll put a car on the screen and it's too big, and they have to change it from 100 to 40, so that they change the percentage. So they're learning percentage without even thinking about it. So that goes along with what Heather was saying about the X and Y happens all the time. So graphing is an early concept that they learn also.
Absolutely.
And they'll run into decimals. So we deal with very young children that understand decimals. Here's an example for decimals. Many times in the code, we need to wait. So you want to wait for 1 second. We do a thing called asynchronous programming, which means everything is timed. And the kids, we say, oh, well, we don't want 1 second. We want 0.2 seconds. The kids just do it. They put a dot down, they put a 2, and they know that's smaller than 1. So that's a quick concept and quick understanding.
Absolutely. I was actually going to use that same example.
Oh, oh, that's good.
Yeah. So as you heard us say, there's a lot of math and coding. And one of the ones that is one of the concepts that's the most important is variables. from the very beginning, the first day that kids set foot in our dojo, they use variables. So when kids come in and do our game building session, we actually have them build a version of Pong, essentially. So we have them keep track of the score. And the only way to do that on Scratch is to create a variable called score. So like I had mentioned, the very, very first time that they're even coding, sometimes they're using a variable. Bob, do you have anything to add to variables?
Yeah, we'll jump into that. But I think one of the important distinctions, we talked about math and we're talking about variables. So the math we talked about before is arithmetic. Mm-hmm. This math of a variable concept, which we will provide a bunch more examples and happens all the time, is algebra. So this whole concept of basically X. What is X? I mean, that is a hard concept for many, many, many people. But these kids are immersed in this concept of a variable. And when they get to 8th grade or 9th grade or whatever grade they take algebra in, this will be a walk in the park.
Absolutely. They'll probably hear their teachers say the word variable and they'll go, oh, score.
Exactly.
Which questions do the kids learn in our dojo? That's a fantastic question. So Code Ninjas has something that they call their Path to Enlightenment, and I'm actually going to show you that right now. At our specific dojo, it's just slightly different than what's on the screen right now, because we prefer to start our kids off with Scratch. We've talked a tiny bit about it before in the presentation, but if you don't know what Scratch is, it was created by MIT as a way to teach very young coders about the concepts behind code and allow them to code without having to memorize a bunch of code and type a bunch of code. They can just go in and move around the blocks and make things happen while learning the most important thing, the concepts of computer science and coding. So we start with that, and then at the very end of the white belt, the kids start with JavaScript. And then yellow, orange, and green belt are all also JavaScript. At the blue level, they start in a language called Lua, and in our specific curriculum, we use it for Roblox as well. Every kid that comes into the dojo for a tour gets very excited when I say that part. And then after that, from purple all the way through black belt, they work in C#, and they also learn a little bit of Unity 3D. So if you don't know much about coding, essentially at the very end of our curriculum at that black belt level, kids will be making games that are 3D, essentially the caliber of games that you would see on a computer or an Xbox or a PlayStation. So it's really, really neat to watch them go through that process of starting with just blocks and ending up with a fully developed game.
That's great.
So we're going to look at Scratch. Bob's going to show you some examples in just a little bit. Like I had mentioned, our ninjas start off with Scratch. We think it's super important for them to have the basic concepts down pat before they move on to any coding where they're typing it out and memorizing things. So Bob, okay. I'm going to hand it over to you for Scratch.
Thank you, Heather. Okay, so we're going to do two things. We're going to talk about this one screen briefly, and then we're going to actually do an interactive demo with the tool so that the parents can see how the tool works. What you see here is a piece of code, and we purposely wrote it. It's very short, and it shows you the use of a variable. So the beginning of the code has a green flag, which you'll see every time we write a piece of code. But the second command you see is set score to 0. This is the variable, and this is when we think the kids can understand this. And it's a score of a game. So they play lots of games, and there's always a score. What this code does is there's a loop. So the next command is a forever. Forever happens all the time. We're always doing forever. So forever just means things are going to run around in a circle and not stop. And that's the way almost every game works, is it's forever processing the next step. What it does next is set X to mouse X. All it is doing is this is a paddle on a Pong game. Wherever you move the mouse, the paddle is going to follow the mouse. If touching ball, there's a ball that's floating around the screen. If the ball touches the paddle, then what happens? We change the score by 1. So that's where you increase the score, and that's where the variable is changing. And so this is not an entire piece of code. This is a snippet of code that would be used in something like a Pong game that would track a paddle, would track a ball, and when they hit each other, it would increment the score. And so this is straight up the first exposure that a child is going to see relating to a variable.
Awesome.
Now, just before we move forward, right at the bottom of your screen here, it talks about different block groups. So these block groups, I'm just going to read this, is motion, looks, sound, events, control, sensing, operators, and variables. Sounds like a lot of stuff, but we want to introduce this because these are the core of Scratch coding. So these are groupings of what is called blocks, and every block is an action or a verb, and these are the groupings. So do you want me to move over and show the demo, Heather?
Yeah, I'll stop sharing my screen and then you can pick it up.
Great. So here we have, oops, not supposed to see that. Where is, oh, this is correct. Okay. Now, what we do is this is a pre-developed piece of code. This is a small amount of code that already exists that shows a background. So it looks like a racetrack. And on the right is a checkered line. So that's a finish line. And so this code that you see here is actually a kind of housekeeping. We're not going to really spend much time on this. Okay, this is just the housekeeping for the game. What we're going to show you is the real part of the game, where we're going to have 2 cars that race each other. Okay, so what we're going to do is down in this area right here, this is a sprite. This is actually this line. This is this finish line. So this will react to the rest of the game. But here is where we create sprites. And this little plus sign with the cat head is a sprite. And remember, a sprite is an object. So it's a noun. It's a person, place, or thing. And when we go to get the sprites, they're all pictures. So a sprite is a picture. Now, before we jump into that, we're going to go over and just talk a little bit about the blocks that are here. Okay, so give me one quick second. This grouping here of dots that are colored are the blocks. And you can read them. They say motion, looks, sound, events, control, sensing, operators, variables, and more blocks. Quickly, motion means move the sprite. So you're going to move it where it is on the screen. Looks means change the way the sprite looks. Change the color, change the shape, change what it says. Sound, we're adding recorded sounds to the game. Events. Events are a little tricky, but you'll see them. They are things like start the game. This first one is an event. Control. Control is loops and conditionals. So a loop, a repeat loop, or a conditional like an if are control. Sensing is getting information like where is the mouse? What type of input? Did one sprite touch another sprite? So this is input that we're getting from the system. Operators, this is all of your math. Variables. This gives us the ability to create whatever variables we want. And the last thing is blocks. Blocks are functions. So they're snippets of code like this that are put into a block that are separate and can be called as a function. That's a little bit higher concept. We introduce that later on, but that's all of your that's all of your blocks. What we're going to do is we're going to create a new sprite. We want to choose a sprite. We're going to have two cars. This is a screen that allows us to pick a sprite. We're going to go in the upper left-hand corner. We're going to type in car, and I like this convertible. So I'm going to grab the convertible, and you'll see the convertible show up on the screen. Now, we're going to have two convertibles race each other, but what we're going to do is we're going to write the code for one, and we're just going to copy it and make a copy of the second car, and we're going to have the two cars race each other. So we talked about percentage earlier, that concept of percentage. Now, right here, the size of the car is 100. This is the natural size of the car. Well, I don't like that. It's too big for me. I want to make it 65. So I type in 65. That's 65% of the weight of the original car. So that's a percentage that the children will learn quickly. So we have our car. Now what we're going to do is we're going to write the code. Now, the code is pretty short. So the first thing we need to do is I'm going to try to use my pen a little bit. We're going to try to go over here. I'm going to go to events. Every piece of code starts with an event that is a green flag. So we have our green flag. So when the green flag is clicked, that starts our code. So we're going to drag this. So everything's drag and drop. So we drag the green flag. The next thing we want to do is we're going to set the car to the left side of the screen every time we start the race. And the way we do that is we do that with a motion. We're going to move the car. So we're going to go to the motion block. So we click on the motion block, and we have a special command that says set X. We only want to change the X. So we're going to drag this. We're going to change the X location of the car. We're not going to touch the Y, just the X. And this number is the edge of the screen. Now, the next thing we're going to do is we're going to have two cars going two different speeds. And so we need a variable. So we're going to pick a variable called, we're going to make a variable. We're going to call it speed. And there's actually two speeds. There's a speed for the first car and a speed for the second car. So we have this little trick where we say for this sprite only, which is a little bit of a higher level concept, but not really that critical at this point. But we have speed, and what we're going to do is we're going to set the speed to a number. And the two cars are going to have two different speeds. And we're going to use the math module in operators to do a piece of math that's not traditional math, but it's computer math, which is it's a randomizer. So we're going to pick this option called pick random. And we use that a lot in gaming. We're going to pick a random speed between 1.0 and 1.3. There's your decimals. And we'll see them later on. The next thing we're going to do is a repeat. So every program has a repeat loop. And we're going to grab a special repeat that is a repeat until. So what we're going to do is we're going to repeat. We're going to keep on moving until we hit the checkered flag. So we're going to grab this repeat, and it's pretty easy. Now it requires another block, a sensing block. But we're going to go into the sensing block, and we're going to grab the condition that is going to satisfy this until. So you're going to repeat until when? You're going to repeat until something is touching something. So the touching is this sprite. So this sprite is the convertible. When this sprite is touching the line, then we're done. So what are we going to do in order to get to that line? Well, we're going to move the object. So we're going to go back over to the motion block, and we're going to pick a motion, and that motion is move. We're going to move a number of steps. So I'm going to throw a question out to Heather. How many steps are we going to move?
Oh boy.
This seems that you're paying attention.
Is it going to stay 10?
No, because there's going to be two cars, both going at a different rate. So they're both going to move differently. So what are we going to use to move the car? I'm going to call you out.
Oh, the variable speed?
Right, the variable speed. So we're going to move this number of speed blocks, right? And so each of them is going to be a different speed. Now, when we're done, when we touch the line, we're going to do a couple things. We're going to use looks. So we're going to go to the looks block, which is going to allow us to do something fun. We're going to, not too much fun, but we're going to say winner. So whoever wins gets to say winner. And after winner, we're going to do a trick, which we're not going to spend much time talking about, but you'll get some kind of concept here. We're going to send a message to every sprite, and we're going to broadcast a message that says end. So everybody's going to end. And we have a special thing when we receive end, we are going to stop this. We're going to do what's called stop all other sprites, scripts in the sprite. That's not important. Really what's important is to keep your eye on this code right here. This is the core code. So as we go through it, you start, you move to the left, you set your variable speed, you repeat until you touch the line, you move speed steps, and when you touch the line, you are the winner. And we have two cars that have the exact same code. So all we're going to do now is we're going to right click on the sprite right here. We're going to right click on that, and it's going to give us the option to copy it. We're going to duplicate it, and now we have two cars. Now I'm going to move the car down a little bit, and I'm going to change the color of the car. So I'm just going to click on that sprite. I'm going to move over to what's called costumes. I'm going to click on costumes. I already have my color purple filled out. I'm going to grab my paint bucket, and I'm going to show you my paint bucket. I'm going to try to show you my paint bucket. My paint bucket right here, I'm going to grab that, and I'm going to paint my car purple. So I got a purple car. So now I'm all done. I got a green car and a purple car. And I want to go back to my code. Now we have two sprites. They both have the same code. See, I'm switching between the two and the code doesn't change. Now, if I remembered everything I was supposed to remember, we can run this and we can see if it works. Now I'm going to maximize. There's some controls up in the corner. Now this seems like a lot of stuff. These kids pick this up in no time. A 7-year-old gets this very quickly because it's all drag and drop and it's all visual. Up here in this corner, I'm going to pick this box. That's just going to make the screen bigger. Let me make the screen bigger and let me try to run the race. So let's see if we got it right. And if you were on the same machine, you'd hear the sound. But we're going to hit the green flag. So the green flag is right up here. We're going to click on the green flag, and we're going to be off to the races. So let's see here. So
Oh
purple
boy.
is the winner. I'm going to show one other quick trick. I know I'm going to bore everybody to death, but on variables, we can show the variable while the game is running. So I go to each sprite and I click this box over here. I don't know if you see this, but this little box over here, I'm clicking this blue box, which shows the speed. Now, when we show the program, the speeds are shown. So there's speed 2 and there's speed, well, the convertible 2 is the name of the convertible and convertible 3 is the copy. Now you can see they have different speeds. So one of them is 1.239 and the other one is 1.271. So obviously the one with the 1.271 is faster and is going to win, and that's the purple car. So we'll just run it one more time and you can watch, and then you can see the speeds are set and you know which one's going to win.
That's something that we use often when it comes to variables like score as well.
Right.
Because it might seem silly to see the speed for a game like this. But in other games where the variable is the score, of course, you want to see your score.
Absolutely. Absolutely. So that's all the fun and excitement. So let me do this. Let me stop sharing. And I know you have a couple things you want to wrap up.
I do. I'm going to hit share screen. We're going to go back to my slides really quickly. Promise there's not too many more of them. Okay, so I just wanted to talk about what our offerings are at the present moment. Don't know why it popped up to that one. There we go. So is Code Ninjas offering any virtual classes at this time? Of course, right now we're living in absolutely crazy times. So we're aware of the fact that not every single person is going to be comfortable coming into the dojo. Of course, you know, we are open 3 days a week at this point, and we are following all of the guidelines from the states and then some. So if you do want to come into the dojo, that is an option. But we're also offering virtual camps and virtual classes. And the camps especially have been super popular, and the classes, of course, have been popular, especially with our clientele from before COVID as well. So the virtual camps are 90 minutes a day of instructional time, and then an additional 60 minutes of playtime on our private Minecraft server. And there are about 1 million topics for our camps. The most popular ones are Roblox and Minecraft camps. There's two kinds of each of those. They've been super popular, as I mentioned. It teaches the kids not how to play the games, but how to modify the games using code to turn it into the exact game that they want to play, which is pretty cool. And then our virtual classes are on a monthly basis. The membership, rather, is on a monthly basis. And that covers a bunch of different classes like Scratch graphics and Python and web development. And we have a couple more that we're going to be coming out with soon as well. So if you're interested in any of those options, just let us know. Like I mentioned, with current times the way that they are, we're trying to be very flexible and come up with new solutions to the new problems that we have.
Plus you have, it's horrible for me to interrupt you. And
okay.
we also have the ongoing one-on-one sessions with all the kids that are there.
Yes,
which
absolutely.
I thought that's important because we really take a lot of care with that.
Oh, yes. The kids love their one-on-one sessions too. Those are virtual, in case you're wondering. So what happens with those is the kids and the senseis will, one kid rather, and a sensei will log on together on Zoom, and they'll go through whichever project the kid had been working on to make sure that they grasp all the concepts and don't have anything that they can't solve. If they're having trouble solving a problem, senseis will help point them in the right direction. So besides that, Bob, is there anything else you want to add? I think I'm done.
No, you got it all. That was great.
Awesome.
You're
So
good.
thank you for coming to our info session. And if you have any additional questions, please feel free to reach out to me either via phone or email. The phone number that goes directly to me is 201-389-6684. So thank you. And I hope you guys have
Thank
a great
you.
night.
Thank you.